Hello everyone. So we're going to be talking about ChatPDFDoc, which is this tool. And what is ChatPDFDoc? It's a data answering RAG tool, and by RAG I mean Retrieval Augmented Generation. Basically, it helps you interact with uh, PDF documents, helps you chat with PDF documents, and it does this by using LLMs and a RAG tool that would chunk whatever data you give it. Then it will carry out a semantic search based on the question you ask, and add relevant context so the LLM can answer your question effectively. So, and basically, you're going to be having a walkthrough on this tool, and we're going to upload a sample document, which is this paper. Attention is all you need. This paper is the backbone for most of the modern LLMs we have today, ChatGPT and the likes. And we're going to be interacting with this paper. So we're going to upload a document, and we're going to upload this attention is all you need document. And we're going to be able to chat with this document, interact with it, and they ask questions in whatever way or form that we need, and here we have it. Document is uploaded. you know so you say you can chat with the following document. So tell me about the topic in the document. See titled, you see document titled attention is all you need, discusses neural network architecture, transformer, solely based on attention mechanism. So this is it. This is the information that is in the document, and here you have it. You can chatting with it. You can say explain attention to me like I'm 5 years old. You just So you see, attention is a way for a conductor to focus on important part of a sentence, just like how you might focus on words the teacher says during a story. So, and yeah, you can see it goes further to explain. Use a dog story as an example, and yeah. So this is the way it is. You can chat back and forth with your document, and it will give you all the response you need. How is this better than ChatGPT or other LLMs? So the way the prompt was crafted, number one, it makes it you can extract relevant data based on your question. It's not going to go outside the document. It's going to give you relevant data to the document, and it doesn't hallucinate. It don't hallucinate, like rather than hallucinate, it tell you it doesn't know. So that is one. Two, it doesn't store your data. So if you're away from the app for about 45 minutes, this file gets deleted and cleared, and you don't need to log in or enter your details. You can just, it's an open source tool. You can go ahead and just chat with your document. And then we're going to be looking at how to even have this on our local. So we're going to do a walkthrough. Okay, so the next thing we're going to do is we're going to see how to host this on our local, and the information to do that has been given. So you either check the blog or you check the GitHub repo. The code is completely open source, and so here we have an empty folder, and the first thing is you git clone and cd into the document. So you have this git clone, and you cd. So you have this, you see all the files, you know. Then the next thing is you create a virtual environment. So since I already have this rag env, we can just say rag env2. So we create uh, a new virtual environment, and we first of all we activate it. We give it permission, rather we give it permission so it can run. Then we run it. So you can see now that this is our virtual environment. So we previously have a base environment, but we are using this now. It's not going to affect it. Then export the OpenAI key. So basically it's by running this code, but this is not the actual key. So I'm going to export the key, then that's off the video, then come back to it. So I've exported the key, and the next thing is we would install our dependencies, and this is it. So now all our dependencies have been installed, and we've added our key to our environment. So we are ready to start our app, and which is we'll simply run using this Python command. We'll run the main file. So this is the main file we're running. Try that again, and there we go. We have it running. It's on localhost 1000. There we go. So this is it, localhost, and you know, we can, there's no uploaded document yet, so you can browse any. So this is you're uploading the same attention document, and successful. You can also delete or clear, you know, and you see that's pretty much how to run it on your local. You know, this is you can, they also test uh, that we can also run. See, well, first of all, you have to activate your virtual environment for this view. Then you run, and you We have our test. This is our test here. We have different test the functions, the classes, the endpoints. You know, so everything we can check it out, and this is how to run it locally. So what we have is this app is running on our system. Is not being Those files are on our system. The vector database, because the RAG uses vector database, so is on our system. So that's how to set it up. And yeah. So next thing, we're going to talk about the architecture stroke design of the service. So basically we have three core services in this app. So we have the API service. We have the ETL pipeline service for ingestion, processing, and storing embeddings into the vector store. We have the query system that collects user query and uses it to search for similar documents, so the similarity search, then augments the prompt, and then this prompt is fed to an LLM, which provides a response to the user query. So this API, the API service is for handling requests and responses, just routing it to the different modules. And the vector store use ChromaDB to store embeddings. So this is the diagram. You can see the API layer, the embeddings, ChromaDB, OpenAI. Is the OpenAI embeddings model we use to convert our text to embeddings. There's a query layer, there's LLM layer, and so those tests now, we have a CI/CD workflow that runs the test. So it must pass the test before it checks for links as well as the test before deploying to production. And currently this is the MVP design. Is Everything is a single server instance, but thinking about scaling this to a production level system, is a lot more complicated. First of all, the files that get uploaded, the user might want to have a record of all the files he or she has uploaded. So the user makes a request, we return a upload URL, a upload presigned URL. We use a presigned URL which pushes the file to S3. Then we now trigger a read. You can have like an Airflow or a Spark server to orchestrate that process of ingesting, chunking, and storing into the DB. The pipeline will also extract, read the file. That's the PDF file. And imagine we have multiple requests and multiple file uploads. So all these file uploads are going on at the same time. And S3 is scalable, or HDFS is scalable to handle different or multiple uploads. And the pipeline now, there will be multiple runs where you can deploy multiple jobs that would be ingesting and chunking and storing. So you have jobs running in parallel and storing into the vector DB. We also have a metadata DB that will store details about the runs, maybe information about relating to the the user requests and number of processing that has been done and other basically surrounding metadata for each job. And this API would be able to handle multiple requests because there'll be redundancy, multiple instances of the API. And we also have a logging system where logs from the pipeline, logs from the query, logs from the API would all feed into the logging system and to be visualized. Then this RAG will basically, to be able to query the vector DB. It would be on like an MCP server where it can carry out search. It can also interact with the LLMs and the get the response, then pass it back to the API. So and you have multiple instances to handle multiple requests from the different users that upload. So this is looking at production level design, scalable and resilient. And to be decoupled. And we use a microservice. We use microservice where this will be an individual service. This will be the data store, individual service running, and you can scale them independently depending on the workload. We use system like Kubernetes to deploy that kind of setup. Storage layer, orchestrator queue, embeddings, and monitoring and logging, optimization. So for fast retrieval from the database, we can batch queries, create indexes, partition data, and even cache. The hottest query depending on the user and how often he frequents make requests to the system. So and a whole list of other upgrades. So it can be for the LLMs. Now there will be option to choose LLMs. You can choose Gemini, Anthropic, and there are many others too apart from OpenAI. For the code architecture, you can see this was the design with extensibility. It was the modular. The code is modular. So you look at the code, the pipeline service, ingest. You have ingest, then you have the pipeline is the one that coordinates the ingest, the processing, storing, and I use the dependency injection such that you can pass a class without you don't instantiate it in another class. But instantiating a class in another class, it makes it creates like a hard couple, so you are coupling it tightly. But if you just passing the object, and when you want to instantiate now, for example, in say you want to look at the controller. Now the controller is the one that has the endpoint, so you can call the different classes, instantiate them with the different uh, arguments, then pass them into the service, into the modules. So um, the different operation runs, and it is good for tests because you can create mock classes. Say for example now the LLM class, you don't need an actual LLM. You can create it like a mock LLM, a mock LLM agent, and apply that and use that in your. You can see the order of dependency, config. The system, most of the classes depend on config. Then there's LLM config, the vector db config, and you have the ingest process class, store class. This one uses the vector db class, and this uses the config class. The pipeline module depends on all these classes, the ones in front, and likewise, as it cascades down, you see the order of dependency, and basically it helps us make updates. You can modify easily. If I want to make this for other LLMs, Gemini, I can easily modify this. uh, I can add like another chat agent that would I will read from uh, I will read uh, I will read from Gemini. So the Gemini, the the actual LLM, um, the actual LLM agent. Okay, so it's gonna be in config. Um, so see, we have chat OpenAI agents. So we can have another one for Gemini, and yeah, that's pretty much it. That shows the structure of the code, um, uh, the different files, and then modules and class, and the back end, the front end. You can see the controller. These are the schemas for passing data. So, and object. Basically, this is object oriented programming, and yeah, that's pretty much it. That's pretty much it. You can go ahead and read the blog, and this is open source. You can download it, as you have seen. You can run it on your system. Yeah, you can run your system, and just fiddle with it. So yeah, that's pretty much it. That's pretty much it.